we're going to be talking about, again, continuation of the Model S body in white. With me, again, is Kevin Hardy. So for those of you who don't know, Kevin Hardy leads a lot of our body structures development as far as new programs that we have coming through the door. So Kevin's going to be very familiar with a lot of stuff that we're going through. In addition to that, Kevin spent roughly 8 years with Munro in a similar capacity that I did, benchmarking at one of our benchmarking facilities for an OEM. So we would cycle through roughly 25 brand new vehicles a year. So times 8 years. We've seen a lot of body in white, so hopefully some of the context learned there will help as we move through this. So let's get started.
And before we go any further, rearward in vehicle, you know, the plenum itself, the toe board and parts of the frontal rocker cap, they're all foam filled for MVH itself, and you'll probably see that through various footage as we kind of look through. But the one thing that that Rich specifically was wondering is this section here, which essentially something was removed here, and I'm trying to think, what was it? We were wondering if it was like a hood prop. I'm not sure. It's just something that stood out that has gone through e-coat and paint and then came off. And I wasn't part of this part of the teardown itself, but we were wondering if it was like a hood prop or something of that nature. Just something that stood out immediately to one of our other body guys. If they were using securing it and fasten it to go through the dipping process, which is pretty strenuous, like on pickup trucks. It's very hard on the cabs, or excuse me, the beds themselves, because they have this whole portion of the rear that's unsupported as they're going through the dip tank and stuff like that.
Yeah, and so there's areas in the vehicle that is very typical to see bare metal or covered up parts, right? So typically the doors are installed. Prior to those processes, they go through the e-coat dip, which gives you a lot of the corrosion protection, and then through paint. Then the doors get actually pulled off.
They typically will split a hinge.
Right.
Yep. Versus take them off, which is why you see this, yeah.
Right, and the doors will go get built up, and then they'll come back to the vehicle. But I think it was interesting on the cowl, as Kevin was mentioning, because it's I'll say a less typical location where we would see bare metal or steel, right? Yeah. It's very typical to see on doors. Almost every vehicle out there is going to have something similar, but just sort of atypical on the cowl there. Yep.
As we start to kind of move rearward, we come up. This is actually where we start to transition. There's most of this, from what I can see, there might be some steel reinforcements inside some of these cavities. It's pretty much all aluminum as we come through here. You can tell here by these kind of concentric spot welds here that help you out and get you a little more hits per tool head as far as cleaning the tool itself. And we work up the door ring itself. We start to get into steel, so you'll start to see some self-piercing rivets to join the different materials coming up. And the welds here they're a little sloppy. They're probably not a huge structural problem for the vehicle itself. I do have some friends that have had to fix spot welds like this on some other high-end cars where they get like BSR or buzz, squeak, rattle issues, and they start chasing these phantom noises. But I would put specifically the Plaid as a car that makes enough horsepower and torque to break itself, kind of in that category where it is a high performance vehicle, and if you did have a substandard joint, you might have a failure, but really we look at this as an issue more from a sealing perspective, and then like a little bit of this splatter here from like a concern to an assembler. You come through and you grab this, cut yourself or whatever it is. That's kind of one of the things, and it's just, I guess, a little unfortunate, that's all. You wouldn't see any of these spot welds that are this close to the edge on like the Mach-E or a Toyota or anything like that. So that it's pretty well dialed, but yeah.
Yeah, and it's just a general note, like looking at all the stuff in this car, clearly there's a lot of engineering in terms of the structure, all the castings, the different, these are, I'll say, big boy OEM things, right? We're not looking at startup elements on a vehicle anymore. We're seeing extrusions and stampings and SPR, self-piercing rivets, die castings, so on and so forth. But this is like the finesse that you get from being a OEM that's been around for 30 years, right? These are some telltale signs when we look at a body in white that are like, the process isn't fully dialed in yet. They're having some quality control issues here. So yeah. It's typically an area that we're always attracted to when we come and take a look at a new body in white. So
And they do have relatively, kind of in Tesla's defense, they do have relatively small flanges. Some other vehicles get around this because they cannot get the accuracy. So they increase the weld flange from like, I'm not sure what this is off the top of my head, but it's probably somewhere in the like 12 to 14 range by looking at it. There's a lot of vehicles that are sometimes in the 15 to 17 range because they cannot dial that process in. So they pay the penalty on the weight of the door aperture and the size of it. On every vehicle that goes out the line, they're costing themselves a little bit of weight. But that's how they get around essentially not being able to control that process, very well.
Yeah. Now, as we move rearward on this, as we're still talking about the door outer, you're probably wondering what these sort of odd aluminum extrusions are.
So are we.
Yeah. So are we. It's very odd. It's something that I can say I've literally never seen another example of on well over 100 body in whites that we've taken a look at. So. The only thing that I can really think of, right? So this is a frameless upper, right? So there's no door frame, metallic frame on the top half of the door. The top half of the door, there's a weird aero phenomenon that occurs at high speeds where there's a negative pressure that occurs on the outside of the door. So it actually wants the air, right? The negative pressure wants to pull the door away from the vehicle. So at high speeds, if you ever, like if you drive a truck and you take it up to 100 miles an hour or something like that on the highway, typically they're not designed to go that fast in a steady state environment. And so what you'll start to get is excessive wind noise. You might have a specific mile per hour condition where all of a sudden a wind noise issue occurs in the door. That's because that door is actually getting pulled away from the vehicle. So as it pertains to this extrusion, when I look at this, I'm like, this vehicle is fast. It is designed to operate at higher speeds than a conventional vehicle. I think that they were having an issue getting the rather substantial seals that they have. And we saw evidence of it when the seals were installed, right? There was some waves in it, kind of looked like a moving caterpillar as you look down the seal. I think that if I had to make a guess, I would say that these extrusions are here to help retain that seal and help give positive fitment to that seal so that in those conditions, the seal and the door are better retained and they're not pulling away from the vehicle. I would venture a guess to say that when we see the next generation vehicle or another iteration of it, I would expect to see that these are probably gone. They may have run out of time in the development process, or given the architecture, meaning how this body stamped outer is set up and the door ring itself, the tumble home, which is the curvature of it as you move up top, it's an automotive term, tumble home. They may just not have been able to do it with the existing architecture. So it's a tough one, but I expect to see it removed in the future at some point.
Maybe, yeah. I mean, one thing I would like to point out to complement that, so with these body side outer flanges, you come through here and you can see it here. These are scalloped for these self-piercing rivets. They're trying to control essentially how much material they're going through. And this might be, I don't know, we'd like to see them get rid of this. It's a separate part. There's two rivets here. It's being bonded. But in some ways, I wonder if they can even get rid of it, because you don't want to have, wherever the mass is, they might have to push the seal profile out. But I wonder if they're just having an issue because they don't want to have a 4T stack up or four layers of material in this area or not. And there also was, in addition to on the fore side of the B-pillar and the aft side, there was another one of these extrusions that ran across the cant rail. It's on the opposite side here, but on this side as well. And that's actually where we first saw them when Tyler was pulling seals off the vehicle.
When Kevin is saying 4T, what he's referring to is the number of layers.
Yep.
So 3T would be 3 panels, 2T, two panels, 4T would be 4. So typically the maximum that people would prefer or be comfortable with spot welding together number of panels is 3T. 4T is less conventional, less common. It's more difficult to get a consistent and quality spot weld through that. And also, you either have to induce significantly higher current or leave the gun in place for a longer amount of time for those instances.
And that's something that starts balancing like the manufacturing. There's oftentimes decisions made of why they don't do certain fastening strategies, like welding aluminum, because of how energy intensive it is. They'd rather just do, and I don't see actually any flow drill screws on this vehicle, which is kind of interesting. So if you were to look at some of and it's similar because a lot of their technology comes from the same area or same expertise. But Jaguar or Ford in their aluminum bodies use a lot of flow drill screws to assemble that vehicle for one-sided operations. But before we go any farther in the B-pillar, you might not be able to see it from here, but there is a Taylor weld here, which is something that we're also like really fond of. So there's a couple different ways as far as layering panels. Here we see a nice small panel, so you can increase local thickness by either layering panels to get the section values that you need, or as you come up here, you get a Taylor welded blank where they're essentially layering two pieces of different material, you know, on a tool head, and they laser weld it or friction stir weld it or something like that. And then now this panel is, you know, like 2 millimeters and 3 millimeters thick, or 3.1, or whatever they want to do, and you can start tuning this structure in based off the sectional requirements you need, and not necessarily pay a weight penalty for having a 2 millimeter panel running the entire length of the pillar itself. So if they're seeing some hot spots in the upper, which is, you know, given that this does not have any substantial
B-pillar
roof bow, they're doing a lot that they can from a theme perspective to balance those load requirements here in the B-pillar upper. So,
but rest assured, Taylor welded blanks are a cost hit. So
yes,
if you want to get your cost down, probably not the best thing to do. If you want to get your weight down, it's a great thing.
Yeah. Well,
so
it's a cost balancing, right?
Yeah.
One tool, so we have one stamp tool to do this versus two panels. So you either get the efficiency and pay the extra money in the technical price of the part, or if you, like many of the Pacific OEMs, will stitch together, you know, these pillars with numerous, you know, various separate panels. So this may be the handoff bracket here, maybe a separate panel. The B pillar may be one whole panel itself being like, you know, like 1.5 mil thick or something like that. And then they might have a separate panel here or a separate panel here, and they're stitching everything together to get the varied thickness that they need, because they're not necessarily, I don't want to say afraid to build it, but they kind of view some aspects of the capital investment a little bit different than some of the big three do here. We like big tools, big stampings, simple, low part count, and they like to amortize that tooling and get a lot of life out of it. So. All right,
maybe just a few notes looking at the floor, and then we can probably move to the back end of the vehicle. You see these major cross members here, right? The side pole impact event, which is where quite literally a pole type shape is going to impact the side of the vehicle. These structures are designed to take up that load. So ideally, you would have a super wide sill section. So that's this part of the vehicle, this whole side of the vehicle. And you would have a lot of open space within that sill section. So during any impact event, the name of the game is initiate the event as soon as you can with regard to the exterior surface of the vehicle, maximize your free crush space. So what that does is it allows the accordion to fully close, right? If you're imagining this like an accordion, you want that to be able to fully close. If I just had a block of steel sitting in the inside of that actually doesn't really help you in the impact event, because you're directly transferring the energy to the inside of the vehicle. So one of the things with regard to changes from an ICE car to a BEV or an electric vehicle is, in many cases, we see larger sill sections, because they're trying to manage the additional mass of the vehicle. The heavier the vehicle is during the impact, the less likely it is to move, which also helps the impact event, decreases the acceleration. So that's one thing. The other thing is they're now relying on the sill sections, both on the battery, right? There's typically a sill on the battery and the body structure to protect the battery, right? Because now the battery, we don't want to have a thermal event due to impact and propagation and so on and so forth. So that's what these extrusions are for, and those are very highly tuned. And then all the holes in them that you're seeing are just lightning holes. So that's just simply taking mass out wherever they can take mass out. In addition to, probably, they're helping with E-coat egress, right? So as it goes through the E-coat dip, the last thing you want is a weight penalty in your vehicle because you couldn't empty out all the E-coat within a section. That's a bad thing. So probably dual purpose there.
And one thing that we spent some time discussing, and you'll see it easier on your side, But these cross-car extrusions they have here, so they don't go all the way to the sill. There's actually probably a 3mm gap between them. And then they have a riveted plate on the sill itself. So there's actually an air gap there, which is kind of interesting. I'm assuming that the local reinforcement is to prevent some like tearing in a side impact event. But I'm curious why. I guess it's cheap and it's easy just to put a flat panel in here versus doing another stamping where you're blending this load path into the actual vehicle itself. But I don't have the answer to it, but it's very interesting to why that execution was done, and kind of like some of the other questions. Something I'd love to kind of discuss about why that was decided to do, or why that strategy was decided on. But it's definitely something that we don't typically see. There's typically a lot of emphasis spent, similar to how it's done here, where there's a handoff interface with an extrusion to get it into the rest of the body structure.
So at the front of the vehicle, when I was talking about how the A-pillar and the body side sort of terminates into the top of the hinged pillar and the upper load beam, right? So right at the front of the vehicle, just forward of the mirror. And we were talking about the stamping process and when material would start to tear. So as it's being stamped, right, a tool's closing over the top of this. Sometimes these are hot stamped outers, which is a very costly process. Some of these tools can cost, $5, $8, $10 million, depending on the size of it. Here, what we're seeing, there's a huge depth difference between the surface of the body side outer and the door ring flange. So ideally, the entire body side outer would be one large stamping. It's going to minimize part count. You're going to get a little bit of structure from it. Your character lines are going to be nice and consistent. There's benefits to doing that. But here, because this, the rear haunches of the vehicle, these quarters, come out so far, which, is a stylistic thing. It's an aero thing. There's a lot of reasons to do it. Because it's so far out, they're actually having to break up this panel. So one, this entire rear quarter is not part of the rest of the body side outer. Typically it is. So that's one thing. So these panels are actually terminated right here. There's an overlapped flange. And then the other thing is it doesn't go all the way to the door ring, right? So in terms of depth of draw of the stamping, they had to terminate it early, because I'm willing to bet that if they were to draw it that deep, this would be a hot spot in terms of the stamping analysis, and you would get a tear right in this area because it's so deep and such a short run, right? If you change this much depth over the full length of the car, no big deal. If you do that over the course of, 300 mils or 100 mils or something like that, you're going to have some serious issues.
So, and as we kind of get to the rear of the vehicle, Jordan had already mentioned that the shift in manufacturing strategy from the sand casting to low pressure casting. So there's been some revisions. If I recall correctly, there was a lot more integration in some ways with this the C-pillar area with it, but you can see here that this is a cast node. You can kind of see the surface finish here. They have some integrated pickup points here as well. And I actually think on the previous iteration, there was some machining operations that they were doing. Don't quote me on that, but I'm pretty sure that was the case here, but they're omitted, which is nice. But here you can see again a little bit of that, the slag come from some of these spot welds. In general, this is kind of a joint I would love to see be assembled, and just where it's coming in, because it's not an easy execution. And then kind of as we come to the overall rear of the vehicle, you have two very, very large extrusions. These on the previous iteration were also octagonal in shape. They've now transitioned to rectangular. They kind of come into the vehicle here itself. And it's, I would say, unconventional, Jordan, that the rails are kind of separate from the trunk volume itself. But what it does give you is, on some cars, you end up with corrosion issues when you do have a more conventional approach where the trunk would come up and over top of the rail itself, and then you have this pocket here where the body diffusers and if you spill stuff in the trunk or whatever it is, there could be issues there where they have essentially a tub, and then they don't necessarily need to integrate it. It doesn't really get you a ton of structural integration. Pretty much what you're seeing here is this actual volume is creating this section here, and then it's coming down here, and they have some overlapping materials and brackets to tie this structure into it. If this were part of the rail, it helps a little bit, but it doesn't really need to be executed as such.
Well, there's no section, right?
Yeah.
It's just typically, not typically, if you got a single ply, right, and it's not a closed section, so an enclosed volume as it pertains to body structures or any structures, you don't get a lot of strength nor stiffness or rigidity from that part. So, by closing it out with another stamping that comes over the top of it, as these rails are in many cases part of the underbody truly, versus being on the upper body, if you will. So if you were to go under a vehicle on a lift, right, you would see some rail sections that are probably hat sections closing out to the underside of a tail panel, like what we're seeing here. It's a different way of doing it. It's interesting. They're probably getting some volume benefits in the trunk area, right? The load floor, as we would call it. But it is interesting. So we've seen it also executed on the Model Y, and I believe a couple other vehicles that are escaping me right now, but maybe we can drop some in the video, right, via text.
One thing I do want to point out with the rear header, so this is the wiring harness pass-through. It's actually like a very tight and kind of torturous path for the harness, so that I'm sure the harness guys don't necessarily like it, but it is tight and relatively well executed for the overall section of the vehicle itself.
Yeah,
you might be able to come in and see a little bit better if you look in through it a little more acute. Yeah.
Yeah, it's a catch-22. Mm-hmm. Routing harnesses inside sections of a vehicle or a door or a lift gate from a packaging perspective and a obscuration perspective, meaning once the vehicle is built, it's the best case scenario, because otherwise everything inside these sections is relatively dead space. It's unused. Whereas if you layer over the top of things, typically there's a static clearance requirement. There's perhaps shrouds or trim panels or troughs or attachments that need to go over the tops of harnesses, like what you'd see running alongside the sill section on the interior of a vehicle. If you can run it inside of a section, you get a lot of packaging benefits. That translates into visibility in your rear view mirror, right? If this section was 20 millimeters taller, you may start dipping into your rear window, something like that. So there are benefits to doing this, but this is very, very difficult to consistently execute. There's almost no clearance for hand space to be able to see the back side of it as it's installed, to ensure that it's positioned rotationally the right way and what have you. So pros and cons. Mm-hmm. Yep.
As with everything in a vehicle.
As with everything. Yeah, we saw Honda route a lot of harnesses within sections.
When the roof was cut off this vehicle, the amount of adhesive that is used here and the overall height is dramatic. There's a secondary bead that kind of comes back here, and you have a little bit of an overlap for the front. Typically, I want to say somewhere between, if you can get it really tight, like a 3 millimeter standoff is often protected for, but typically like 3 to 6 is often. This is probably closer to 10 or so. So it's a little excessive. It's a lot of weight. Again, it's kind of one of those consumable items that are hard to account for, and if you don't keep track of, you just pay for it on every vehicle. Both in the plant, you're paying for it for a consumable item, and then on the weight side of the vehicle itself. And I know, Jordan, we were kind of talking about just the secondary like sealing or kind of like quality check. So you have some stuff here you can see which have gone through paint, and then you can see with another type of sealant they've come back and done some touch up here, and then some touch up throughout here as well. Obviously EVs are, with how quiet they are, they're very sensitive to any sort of rat holes or cavities within the body creating noise, but ideally you'd like to try and get some of that stuff in your first hit with your actual sealing strategy versus have to come back and do it again. It's another process, some additional labor. But overall, I think with the vehicle, there's a lot going on. There's a lot of different manufacturing processes. There's risk here, and they took the risk and they did it. So I think you can always kind of tip the hat to Tesla with respect to that. Some there might be some requirements or some legacy considerations that would prevent other companies from maybe following through as quickly or even in a similar manner. But you know, in general, it's I don't know. It's my favorite of the Tesla vehicles that they make. I think it's, especially the current iteration, is the best looking. So.
All right, everyone. Thank you so much for sticking around for round 2 here on the body structure. Hope you enjoyed it. Real quick, again, just wanted to give a shout out to Sabic. Thank you for supporting the road trip as well as the teardown. And once again, for Corey's sake, go ahead and hit that subscribe button. Thank you.